In today's lesson, we are doing local linear approximation. So let's just first think about what those words even mean. So approximation, so we're not getting exact answers, we're getting close to answers. And then think about linear. What have we been doing all year long that relates to the linear function? If you think about tangent lines are linear functions. So we are using tangent lines to make approximations of our function. And as part of our intro to the lesson, I'm going to look at a concave up and concave down graph. So concave up, and here we go, concave down. Unit 5, we will revisit concavity a lot, but for now, just kind of the basics of what a concave up is and what concave down is. Okay, so now I want you to imagine a tangent line on each of these functions, on these graphs. So what we are doing is we are going to use a tangent line. So if we have the equation of a tangent line, we are going to use that to make approximations on the function at certain values. So using the tangent line to get close here. So if it's tangent at this point right here, we obviously want to be close to this value as we're approximating, because obviously here would not be a good approximation. Okay, so now look at both of these graphs. If we are if it's concave up and we're using this tangent line to approximate here, it is an underestimate. Our y value will be smaller than the actual value. Where if our function is concave down and we use our tangent line to approximate, our value will be above. Our y value will be an overestimate. Okay, so let's get into some practice problems. Okay, so I'm going to give you some information. Let's say we have a function f of x and it is concave up. And let's say f of 2 is 17. And then I'm also going to give you the information that dy dx equals 2x plus 3. And here is our goal. Our goal is to use the tangent line at x equals 2 of f of x to approximate f of 2.1. So to just give you a quick visual, we have something that's concave up. We have a tangent at x equals 2. And we are going to use our tangent line at 2.1 to approximate f of x at 2.1. So let's use this information to write a tangent line. We know x and y, and then we have to find m. Well, m is the slope. Well, we have the derivative, and derivative gives us the slope when x is equal to 2. So y minus 17 equals, okay, here 2 times 2 plus 3 is 7. And then x minus 2, I'm going to convert this to slope intercept. So I have 7x plus 3. Okay, so now we're going to approximate f of 2.1 by using our tangent line. Let's plug in 2.1 here. 7 times 2.1 plus 3 is 17.7. And because the function is concave up, it is an underestimate. Okay, here is the information for our next example. So function f is concave down. And f of negative 4 is 2. F prime of negative 4 is 5. Our goal is to estimate f of negative 3.8 using local linear approximation. So when you see this, that means find the tangent line and use the tangent line to approximate values of the function. Okay, so here's our x, here's our y, and because this is derivative, here's our m. So y minus 2 equals 5x plus 4. So I converted that to slope-intercept form, and then we are going to use our tangent equation and plug in negative 3.8. So 5 times negative 3.8 plus 22. So you should get that y equals 3. And because this function was concave down, then it is an overestimate. Okay, last example, f of x equals 3 sine x plus 2, and that is concave down on the interval from 0 to pi. So it's a sine function, so it's going to be concave up and down, but on this interval, it's concave down. Okay, and the instructions, we're going to estimate f of 3 using local linear approximation when x equals pi. So right now, all we have is this x value for our tangent equation. So let's find y by just plugging in pi here. So 3 times sine of pi plus 2. So that's 0 plus 2 is 2. So y minus 2 equals, I'm going to have to find my slope, x minus pi. So finding the slope, I need the derivative of f and plug in pi. So the derivative would be 3 cosine x, and we need to find the slope at x equals pi. So 3 times cosine of pi, so that equals negative 3. So negative 3 here. If I'm going to convert this to slope-intercept, I'll have y equals negative 3x plus 3 pi plus 2. And then I want to evaluate it at 3. So negative 3 times 3 plus 2 plus 3 pi. So you'll get 3 pi minus 7. So you could leave it like that. That's its exact form. If you have a calculator, you can type that in and it will equal about 2.425. And let's think about this. This is concave down, so it will be an overestimate. So there is your full video on this local linear approximation. Good luck.